Just a quick int- just a quick introduction on behalf of SP France. Yes, so sure. So as you guys may be aware of, recently SP France has changed its board. It's usually a board that stands through 2 years. And we're always, of course, looking for additional volunteers and members from diverse companies from the oil and gas, but also nowadays the energy industry within France. So this is our current board with all our colleagues. You might find further details on each one of these board members through our LinkedIn page along with their bio. And throughout the next weeks, we will be doing some spotlight features through our social media, highlighting each one of our board members so we can get to know them a little bit better. We have our President Carla Castillo, myself, focusing on conferences and programs, and kindly helping us in the events today and always our Constantine and Scarlett, which are also here online. And joining us from Po, it's our YP director, Ana Claudia, so being supported with Link Fei and other volunteer members, including Fabiola and Diana from the communications team, as well as Happiness and some other members, which let you afterwards if you want to contact through either LinkedIn or chat, and as well as Maureen helping us so much with the communications. So, just to remind everyone, we believe that everyone that is attending is already a member of SP, hopefully, but if not, or even if you are, it's always a good reminder to not forget what's the added value and tangible advantages of being an SP member. So it's mainly four main lines of action that SP can contribute to one's career and development. There's, of course, first and foremost, the technical resources. So SP is the largest and main society within the oil and gas industry, and now going towards the energy industry. So it's the oldest and most complete referential on documents, papers, white papers, presentations. It has many technical journals, including the most famous journal, which is the JPT, Journal of Petroleum Technology. But there are also some other online publications that are the oil and gas facilities, the way ahead, and for also HEC now. We have the largest database of papers called One Petro. And of course, you may be familiarized with Wikipedia. There's the equivalent within SP called PetroWiki, and as well as a platform of digital events, webinars, and masterclasses on the platform called Energy Stream. We invite you all to visit sp.org to see all this and many more advantages. Of course, there's also the let's say physical world advantages, not only on the virtual side, which are the networking opportunities. I myself, and I guess many of our colleagues that are joining us, both members and board members, had for sure witnessed this firsthand, being able to network with colleagues both on the technical side as well as the those seeking opportunities in the job market, or students entering the job market, or simply finding all acquaintances. It's one of the most precious added values of SP internationally. There's a professional development. There's several tools for this. One, for instance, is the competencies tool, where one can find any competency gap that one might have to work on a specific métier or discipline. There's also several trainings, workshops, a lot of books, and it's one of probably one of the strongest elements. There's also the uh, mentoring program from SPE and many others. And of course, we recognize our members by either leading leadership, technical, or service awards to either students, young professionals, senior professionals, or veteran members. We do this recognition in many countries at the national level, but for sure at the regional level. For us, it's the European awards, and then there are international awards as well. You're always welcome to nominate any fellow member. There's no need to receive any green light or permission from any other entity within SP. So anyone can nominate any other member, as long as they're, of course, members with their active fees, with fees up to date. So, what are the main activities of us for SP France in particular? So, we have our monthly conferences, like the one you're attending now, whether online or in person. We do hybrid events very often, and we have a very strong presence, almost half and half between Paris and Pau. As you might see now, we have our colleagues joining from Pau, and ourselves. We're here in Paris. Not only in La Défense, we're spread across different industrial areas, and We have, of course, the networking events, the ones we do ourselves. We have strong collaboration and partnerships with many companies and important stakeholders within the energy industry. We support young professionals with a program which I'll show in just a moment called Beyond the Borders, BTB. And we support also student members, mainly through our very famous championship event called Petro Bowl. Of course, there's mentorship, field trips, and many other elements that we invite students to attend. As a reminder, SP is free for all students, so this is an attractive element. And for young professionals, especially first recent graduates, there's a special membership free price as well. So this is some just quick snapshots. SP France just became 40. It was our fourth anniversary, and we had a very strong event with a strong presence from many of our stakeholders, partners, and sponsors. In the upper picture, you can see our TotalEnergies CNP director, Nicolas Terras, but we have also a roundtable with many SVPs as well as SP International President, bottom middle, and all our volunteers, including 25-year-old members. And this was in Arts et Métiers in Paris, and it's a very nice event. We also need to thank our sponsors for the event, TotalEnergies, SLB, Subsea 7, and Technip FMC. If any of your other companies or yourselves working within a company or entity that would like to support financially or even through men, women power or lectures or field trips, support SP, we're always thanking and appreciating any kind of support that can be given. There's the Beyond the Borders program, which is a very interesting program that started as a co-creation between SP France and other European sections that tends to happen every 2 or 3 times per year, in which 20 to 25 young professionals visit different sections. The costs are covered partially by either the hosting section or the section to where they belong. We had the recent one here in France after many years returning to where it first started. We had a full day in TotalEnergies, but also in other companies. A lot of lectures on soft skills, development, technical topics, and so on. And of course, Petro Bowl, many of you might have seen recently in social media that IP was one of the top finalists in the international version for this year. And we hosted the qualifiers for this thanks to the support of Technip FMC, TotalEnergies, and other companies here in La Défense. And we also have 2 key messages to pass on. One is that you're, of course, watching this event, but we have already our next event mapped, which is a distinguished lecture. This is a very senior lecture sponsored by SP International that goes around many countries with a top level presentation. This will be advances in carbon simulation, unveiling the potential of single phase retarded assets, SPRA. It will be on November 19th. It will be a hybrid event. So for those who would like to attend in person, we'll have the event here in La Défense in TotalEnergies, 5:30 Paris time. We'll also broadcast it online, and we'll have an exclusive after-work session, networking apéro with those that are attending. And we have to close this quarter on December 3rd, an event from the TotalEnergies One Tech specialists from Pau, working on satellite emission detections, on its challenges and futures that we invite everyone to attend as well. It will be hybrid, so those in Pau can attend in person. For those in Paris, it will be online 4:30. And just to close out, this is the distinguished lecture for which we'll send you guys in the next days already an invitation. And we invite you, of course, as always, to follow us on social media. We're starting Instagram, but we already have a strong presence on LinkedIn where you can follow us for all the events and latest posts, and even our own event, which is being streamed today over LinkedIn and YouTube. And of course, for members, you'll receive this invitation as well by email. This will be on November 19th. And so not to hold you more, I pass on the word to Ana Claudia and Info. Thank you so much.
Thank you. Yeah, sorry, we need some, oops, to move this back. Do this window. Oops. Sorry. Okay. and I will. Can you let me know if you can see the slides now?
Can you hear us? Can
Hello?
you hear us?
Hello?
Yes, we can hear you, we can see you. The slides are displayed.
Okay.
Please go ahead, thank you.
Yeah, so I will just give a brief introduction in English to the audiences in Pau. So nice to meet you all here. And I think this should be one of the biggest events we have held in recent years for the maybe geoenergy part of UPPA. And considering today's, I mean, it's a very good feedback because we gathered almost 20 people here. And this is a very good feedback for us. And so hopefully, receiving today's feedback, we have gathered so many people, and I hope in the near future we can hold this kind of event more often. And we also hope you can join our future events. And maybe it's again a joint event with the young professionals and together with the student chapter. And it's very appreciated that you can join us. So today's hybrid event, we will have two presentations, and the first one will be a presentation by the young professional part of the SPE France, and our presenter is Claudia, and she's now a reservoir engineer at TotalEnergies, and so I will give the speech to her. Yeah, thank you.
Thank you, Linfei, and thank you, Rodrigo. Good afternoon, everyone. I hope you're well today. My name, as Linfei said, is Claudia. I am a reservoir engineer working for TotalEnergies, but I'm also a product owner of the tool that I'm going to present today, which is ForCFR. That stands for Forecast, Optimize, and Reduce Carbon Emissions. Apart from that, I am the young professional chair of SPE France that Ricardo also introduced right in the beginning. So throughout the years, I had the opportunity to contributing to some publications and initiatives that focus on sustainable reservoir engineering and also climate conscious innovation. And today I have the privilege to be here to be presenting my work to you. ForCFR, again, that is a topic and a tool that sits at the heart of both environmental responsibility and energy transition. So let's dive into it. Before we actually dive into it, here is a safety moment that we'll go through on the future of AI consumption. So in late November of 2022, we were all surprised with the launch of the famous ChatGPT. I think we are all aware of ChatGPT today. And what's even more interesting is that we were really curious to see what actually this AI bot does. So within the first 5 days, ChatGPT had 1 million users. And then after 2 months, it had 100 million visitors. And then by this year, ChatGPT was having around 400 million weekly visits. So we have here an exponential growth. And I don't even want to imagine how many visits we have by today. It must be really a lot. So then there is a study that was conducted around August 2023 and August 2024 that revealed that in the United States, the data centers, they had been responsible for 105 million metric tons of CO2 emissions. Let's pause here. These emissions are just slightly less than the entire commercial aviation sector, which is around 131 million tons of CO2. So we're not talking about a flight from Pau to Paris or to the United States. We're talking about the entire aviation sector within a year. So let's keep this in mind that when we're using AI, we are actually emitting because we need the power to generate all the tasks that we ask ChatGPT to actually perform. So all the summarizing, the generation of pictures, this is taking power, and consequently is generated CO2 emissions. So then if we look at the plot below, given by the International Energy Agency, that shows the estimated electricity demand from traditional data centers, AI data centers, and cryptocurrencies. We can see there that for the year of 2022, we have the energy demand for traditional data centers and cryptocurrencies. But then it is estimated that by 2026, we will have an increase of the power demand for the traditional data centers, a little bit more for the cryptocurrencies, but now we have an addition. Now we have AI data centers. So we are consuming more power for the AI data centers, meaning that we have created another problem for the CO2 emissions. Then there had been other studies that were trying to understand the energy consumption and the CO2 emissions on using the AI. There was a study done by Carbon4 and Meta. So this study was trying to assess the limitations of estimating the CO2 emissions. And they concluded that the tip of the iceberg that you're seeing in the image on the most left side is actually responsible for the consumption of electricity by the GPU. So the GPU is actually the unit that is responsible for processing graphics for the ChatGPT, for example. And then what's below the tip of the iceberg is what we cannot see. So all the emissions that we are able to estimate, they're only the tip of the iceberg. All the other emissions, which are more than half of the tip of the iceberg, we are not able to accurately estimate. And these emissions, they are mostly for training of data. We know that with AI, we need to try to train data so we can be able to recognize some images and etc. And we also have the emissions that are responsible for manufacturing. So all of these emissions, we are not actually able to estimate it properly. So let's probably think when we ask ChatGPT to summarize a text, for example, the emissions that they show us, they're probably only less than half of what we're actually needing. So let's start from here. And there was another study that analyzed AI models. I believe you're very familiar with this model. So Copilot, Google AI, and of course, ChatGPT. They analyzed the impact of the tasks that we asked the AI models to perform on CO2 emissions. And we can clearly see in this image on the most right side that the task that generates most of the emissions here is image generation. So now I look at all of you, and I have to say that we are all guilty. We are all guilty because we have all tried to generate images with ChatGPT. And there has been a very, very high affluence of people trying to generate images with ChatGPT. So the next is multitask summarization, and followed by image captioning. So maybe the next time we ask ChatGPT to do something, we'll be more conscious from now on, and also about the emissions that we are putting out there. And remember, we need to leave the world as we found, clean, and keep it sustainable. Okay? So let's dive into ForCFR now. Here's the agenda for the presentation. We'll start with a business case, then we'll go straight into the ForCFR model, and then I'll share with you some of the use cases, and then I'll show you a real example that we performed with Angola Block 17. So as for the ForCFR model, before we actually construct a ForCFR model, we need to analyze a field, a production field. We need power. That's what's written here. But actually, we need power to be able to produce, but also to produce this power, we need to burn fuel gas. And by burning fuel gas, of course, we'll have CO2 emissions. And what we have seen based on experience is that most of the power requirement in a field comes from reservoir management and export. I would say reservoir management because we have water injection, so we're going to use a lot of water injection pumps. For gas compression as well, we're going to use a lot of the compressors to compress the gas and also for the export. So before we actually think about tackling the CO2 emissions, we need to look where do we have the most CO2 emissions and start from there. And then we're going to see all the other parts. But this is the main part, so we usually attack from here. So then we can actually do that with ForCFR. So actually, ForCFR is a solution for the industry because what was happening before is that some engineers, reservoir engineers, well performers, they were evaluating the production profiles and optimizing separately. They wouldn't communicate, they would do whatever they had to do, but separately. And then they would take this production profiles and input it as in a CO2 file, which at the time was an Excel file. And they would try to calculate the CO2 emissions associated to their production profiles. Then they had to test different scenarios. Let's say they were trying to close a compressor to reduce emissions, but then this would take half a day. This is a lot of time. And let's say you have 20 scenarios, so you take 2 weeks to analyze 20 scenarios. It's quite a lot. And in oil and gas, time is money. Then ForCFR came as a solution because now you have your integrated CO2 emissions within ForCFR. So now you don't need to look only at the production profiles and then go check the CO2 emissions. You have both with ForCFR. So you use your production profiles as input, and ForCFR gives you your CO2 emissions within seconds. And then you can choose to optimize your production with ForCFR still, and you have, again, your CO2 emissions straight away in the results. So this has been done by communicating between different disciplines. So now I have reservoir, I have well performance, I have process, all of them communicating and coming out with different, let's say, opportunities to be able to reduce the CO2 emissions from their field. So now they can work together, they have faster evaluations, and then they can do easier opportunity screenings because they are working together. So let's say if I'm a production engineer and I want to stop water injection. Process will tell me, no, you cannot do that because my facilities, they're not ready to be shut just like that. So now we have communication and they're working quite well. So this will help all the engineers make decisions based on intensity optimization. So now you don't have to look only at CO2 or only at production, but you look at both. So this is actually a gain. Now we have ForCFR around the globe. This is where our presence is felt. But to note here that our presence is only felt within TotalEnergies affiliates. The tool is not yet commercialized outside of TotalEnergies. So we just deploy within TotalEnergies affiliates. And as you can see here, we have our presence in Suriname, Brazil, Namibia, Angola, Congo, Nigeria, Uganda, UAE, and we are starting some projects very soon with Mozambique and India. Is there anyone from these countries in this room? Okay, where are you from?
Nigeria.
Okay.
Brazil.
Brazil, okay, very good. And online, if there's anyone from one of these countries, please, can you show an emoji? Thank you. So now I show you here the ForCFR interface. This is what actually looks like. And as you can see, we have, okay, I'll just activate the pointer for the people online. So as you can see here, we have the schematics and we have here I would say, a mimic of the production inlet of a production facility. So we have as inputs the production profiles and the equipment performance curves. So the equipment performance curves, they will be used within this equipment here. So we are able to calculate the power demand. Once we have the equations integrated into the model, we run the model, and the model runs behind it with a Python script. Once the model runs, we have as outputs the GHG emissions profiles. And this is actually our final results. And then you can decide whether you want to integrate your production profiles with your production forecasting tools. Production forecasting tools, I'm talking about Intersect, Gap. So you actually take the script that is generated by ForCFR, you implement it in your production forecasting tool, and now you have your CO2 integrated forecast. Then, we move to how we construct a ForCFR model. The first step to constructing a ForCFR model is the data collection. This is a very, very important step because this will ensure the quality of your model. So the quality of the data you have will ensure the quality of your model. So here, we usually need the description of the process. It can be a PFD, so process flow diagram. We need the equipment performance curves. For greenfield, we don't have this performance curves. We will have rather the theoretical curves. But for a brownfield, we will have the historical performance curves. And then we will need your production forecasting tool, which is usually a gap model or an intersect model. So we can couple your production and have the integrated emissions profile. A file that we usually use that is very important is the process quick look assessment, because it provides us the assumptions of the equipment, the availability of some equipment, and the way we need to operate some of the equipment. So all this information is actually very important. So now to the ForCFR modeling, as I mentioned just now, we need surface process. So we try to mimic the process, but simplifying even more. So we try to model all the consumers that are important for the CO2 emissions, the ones that consume the most power in the field. Then we try to balance the model by matching the material, power, and heat balances. This will also ensure the continuity of your model. Then we have the performance curves integration. As I mentioned before, we need to integrate our equations so we are able to calculate the power demand for each of the equipment. Once we're done constructing our model, we move to the simulation. As I mentioned before, we have a Python code behind ForCFR that runs the model, the entire model. So you can either decide either to run the model in a standalone mode, which is what we call running in place. So you don't need to couple your model with any production forecasting tool. You just load your production profiles and you have your emission profiles straight away. Or you can choose to couple it with a production forecasting tool. So intersect or gap. In this case, you will have your script generated and automatically linked to your reservoir model. And all you have to do from this point onwards is what you do as a reservoir engineer. You just run the simulation and that's it. You have your production profiles and your CO2 emission profile. So if you look at this plot right here, you see that you have your production profiles with your GHG intensity. So as easy as it is, you have your CO2 emissions with your production profiles. You will be able to see long-term, short-term, whether you have any opportunity to reduce the CO2 emissions. Then ForCFR can be used for a lot of cases. But here I'll start with the long-term plan, which is the case we use the most. So in the long-term plan, we usually assess a lot of CFR projects. CFR project stands for carbon footprint reduction project. So here we are able to assess the impact of these projects on a long-term basis. So let's say you have a compressor rebundling coming in 2030. So you can actually put that in ForCFR. You can instruct the model to do the rebundling, and then you'll see the impact on your CO2 emissions over time. Then you can use ForCFR model also for asset optimization and planification. And here we have some asset optimization ranging from short-term to long-term. In the short term, as I just mentioned, compressor rebundling, you can assess whether this is a good initiative for your field management or not. And then on the long term, you can have gas lift optimization. You can see how it will behave throughout the years and whether you will be able to reduce the CO2 emissions throughout the years. Then another case for the ForCFR is development studies. So the development studies, they are usually for greenfields. We can use ForCFR to evaluate different scenarios, whether you want to drill an infill well, whether you want to add a recovery mechanism. We have done a lot of studies with EOR, and we were able to assess whether the EOR technique was actually giving us less emissions or not. And you can also assess well pattern, whether a certain well pattern will give you more emissions or not. Then you can probably choose among different well patterns that will optimize your CO2 emissions. Then we move to the use cases for ForCFR. We have done a work on a brownfield, which is Angola Block 17. And in this case here, it was the FPSO 12. So we tried to analyze different water injection scenarios. And here we listed 4 water injection scenarios. So initially, we analyzed that the water injection accounts for 35% of the total power need, which is a lot. So remember, as I said in the beginning, we need to first look at the equipment that consume the most power, and then we need to start from there if you want to reduce the CO2 emissions. So this one accounts for 35% of the total power need. So we are going to try to reduce the CO2 emissions from here. So we've listed 4 cases. We have listed 3 cases apart from the base case. The first one was to reduce the water injection by 30%. The second case was to inject water at full capacity. And the third case was to inject water intermittently. So 1 month on and 1 month off. And this is where it gets interesting. Question. In the reduced water injection case, which is the case where we reduce the water injection by 30%, and compared to the base case, what is the long-term impact? So you have answer 1, production increases and the intensity increases. Second one, production decreases and the intensity increases. Third, production increases and intensity decreases. And fourth and last, production decreases and intensity decreases. I will give you 1 minute or 30 seconds to 1 minute to think around it. And we'll see what are the answers.
And for the audience joining online through Zoom, I kindly invite you to respond to the poll that you are seeing right now on your screen. We will use this information to be shared with the rest of the audience later.
Thank you, Constantine. Think this through. The answer is in the graph.
So right now on Zoom, we've got 18% participation rate. So I invite everybody to respond. There are no right and wrong answers. So we really need your participation, please. Okay, we are reaching 30%, still way far from the target. So please respond to the question. Great, we're almost half of the audience responded.
Okay. Do you have the answer here? everyone?
Okay. So probably the last chance for the audience in the Zoom call to provide the answer. And Anna, please let me know when you would like me to mention the results of the poll from Zoom.
Yes, sure. Thank you.
Okay, we're almost there. Please feel free, those of you who haven't voted, please do that. Okay. It's interesting. In the poll, we have a clear leader, but then the second place is actually same, for two answers. And one answer has not been selected at all by anybody.
Okay, so we will know first about our audience here, and then we'll come back to the online.
Sure.
So who goes for answer number one? No, no one? Number two? No one? Sure? Number three? Okay. And number four? So the winning one is number three for the audience here. And what about online?
Okay, so online, the first answer, which is production increase and CO2 increase, nobody selected that. Then
Okay.
the second and the fourth got equally, funny enough, 25% for each. So production decrease and CO2 increase, and production decrease and CO2 decrease got 25% each. And then half of the audience responded with the number three, which is production increase and CO2 decreases.
Okay. Okay. Thank you for your answers. Actually, I know it can be quite deceiving, but the answer is actually number two. I know you must be asking yourself why. So by reducing the water injection by 30%, we actually reduce the power need. That's correct. However, we have less pressure support in the reservoir, so we will be losing some of the production. And then over time, we will have some of the gas at surface. So when we have more gas at surface, we need to use more of the compressors. So we need more power to compress the gas. So actually, we increase the emissions because we are reducing the pressure support in the reservoir, and because we have more gas associated to this production. So yes, please. Yes.
Okay,
Yes.
this is why you need a compressor.
Exactly.
Should have said that.
Yes. Sure, I'll take note on that. So yes, it's because we're also recycling the gas, so we need more power for that as well. So you were close, not too far from the right answer. I believe online we had 25% going for this answer, so congratulations. So we move forward. Still on the brownfield, here we can see the impact of all the cases on CO2 emissions and production as well. So the most doable case is actually the base case. So to say that probably we wouldn't look at long term, we would try to use each of the opportunity at short terms altogether. And then for the case where we inject water at full capacity, we will have a lot of emissions because we're actually needing more power to inject the water. And then because we are recycling the water and we will need the water treatment unit as well, we have even more emissions related to that. Then for the case where we are injecting water intermittently, the month where we are not injecting water, we will have less pressure support for the reservoir. So then we'll be close to the bubble point pressure, and we'll have a lot of gas at the surface. So we will need more compressors working, so more power for that, and consequently more emissions. So repeating, probably we should look at long term. Maybe we can start with injecting water at full capacity when we still have the plateau, and then we move to the reduction of 30% in water injection, and then to the other one. But to say that it's a compromise, you shouldn't look only at the CO2 emissions, but you should look at the intensity. So emissions per barrel. This is what you should look at, and not only the production, because actually, when you talk to operations, they say, no, we don't want to sacrifice production, but we need to do something. We are actually in energy transition. We need to do something. And at this point, we need to look for a threshold in which we can reduce the production. Let's say, for example, we can accept to reduce the production by 1%. I think it's acceptable. It's almost nothing. But in this case, we need to actually convince the operations because they don't want to lose any production. But we need to show as well the bigger pictures, which is the reduction in CO2 emissions. So next, we have here an application in a greenfield. This project we did on Suriname. And here we were trying to see the impact of the inflow control valves in wells. So this inflow control valves, they are a type of intelligent completion. They help us control the production of fluids in a well. So in this case, we're trying to reduce the production of water. So we noticed that the water injection in this field was accounting for 25% of the total power need. So we ran our models, and we have the base case in the plot below. In I think it's red. We have red in the base case, and then in green we have the same case, but now with the ICVs. So we can see that we reduced the GHG intensity by 1/3, which is quite a lot, meaning that now we have less production of water, but we still maintain the same production. We don't lose production, we we actually reduce the CO2 emissions. So we actually gain, which is quite good in this case. So next, we are going to move to a real case in which we did a very, very large project for Angola Block 17. This project has been featured, or it's going to be featured in 2 weeks in ADIPEC conference. So if you would like to go into details, you can actually look for this project at SPE. The paper is available there. So in this study, we're trying to reduce the fuel gas consumption at 0 capex, so with no cost. We have listed 38 opportunities. So we all came together, all the disciplines, reservoir, well performance, process. We all came together, we did a brainstorming, and we identified 38 opportunities. Unfortunately, not all of them have been retained. Only 16 have been retained because the other ones were not feasible. And among this 16, we have 12 that have been listed for CLOV. 2 of them have already been implemented. For Dahlia, we have 10 that have been identified, but only 3 have been implemented. For Girasol, we have identified 8. Only 1 has been implemented. And for PAS4, we identified 8, and none of them have been implemented yet. But it does not mean that they're not going to be implemented. These are part of a long-term plan, so it means that it will come with time. So we have predicted everything already using ForCFR to check the impact of all these opportunities over time. And the result you can see in the plot right there, where you see the line of the LTP 23, which is the baseline. And then we have the line of the opportunities, which grabs all the 16 opportunities that we have recommended. And you can see that there is a gain, and this we can account for 9% in terms of gain. So we were able to reduce the overall GHG emissions by 9%, and this at 0 capex. So it's been quite a successful work. And this explains why it's been published at UPPA. So we have come to the end of our presentation, and the key takeaways here are that we have seen a very, very innovative tool that integrates the GHG emissions along with your production profile. So you can actually apply this on brownfields, as I mentioned, Angola Block 17, and also for greenfields, as I showed for Suriname. And the integration is quite easy with your production forecasting tools. So I'm talking about Intersect and Petroleum Experts. You just really have to generate your script, and it's quickly attached to your production forecasting tool. And all you need to do, run your simulation, sit back, and then once it's done, you just see the results. Then you gain with ForCFR. You only gain in terms of time. As I mentioned again, in oil and gas, time is money. So the more, the less you spend, the less time you spend working on something, the better. And we need to ensure the efficiency as well. So with ForCFR, you're actually able to gain a lot of hours in your work, because you can do your profiles evaluations for CO2 emission within minutes, even seconds. And I'm not exaggerating. You are able to do numerous use cases with ForCFR. I've explained that we can do long-term plans, asset optimization, and also development studies, especially for greenfields. And this tool has been deployed in a lot of TotalEnergies affiliates, and the first one has been in Angola, and we are trying to go even further away to cover most of the TotalEnergies affiliates. And of course, I couldn't finish the presentation without thanking my team. They are actually the reason why ForCFR exists today. There are plenty other people involved in the team, developers, and they are the ones who make it happen for the tool. The tool is still in development, and we are always trying to work to provide the best user experience. And that's all for me. Thank you, and I'm open for questions.
Thank you very much, Anna. I would pass the floor to Rodrigo, because we've got one question already coming from LinkedIn. Rodrigo, please go ahead.
Thank you, Constantine. And just before I open the question, thank you so much, Anna. It's an excellent presentation. Thankfully, I had the privilege of seeing some of your presentation already internally, and really nice to see this version externally. Especially congrats on the paper that you guys will present. And I might be a little bit biased, but I think it's one of the best tools we have internally, and putting the emissions reduction within the first stage of development and optimizing the integrated development of a field, not being a consequence, but being one of the initial variables to consider. So it's really great change of mindset, and technologically will bring a lot of additions, mainly of course to reduce our company emissions. We have already a question, like Constantine mentioned, from our fellow member Thomas Parantou. We have a question saying, on your graph slide 11, how do you explain the CO2 intensity curve increase with time while the production profile decreases with time? I don't know if you want to go back to 11 and you want me to read the question again, Anna, or was it? I think it's referring to the chart that's in the bottom right that shows exactly. I think it's in the bottom right that shows the fact that production is decreasing with time as it's expected. But his question is, why is the GHG intensity, the purple curve, increasing? I myself might feel tempted to cheat and answer, but I'll let you, Anna, comment.
Yes, sure. Thank you, Rodrigo. So we're talking about long-term, right? And this is to respect to GHG intensity. So we are talking about the CO2 emissions per barrel. So as production is reducing, we still have emissions. So that's why the curve is still increasing over time. So if we look at the CO2 emissions per barrel, the CO2 emissions are increasing, so which is the upper denominator, and the lower one is the production, which is decreasing over time. So we still have emissions, and that's why the curve is still increasing. I don't know if I've answered to the question.
Yeah, thank you. And I think it's quite clear. And it's at first sight might seem counter logic, but then thinking about it makes a lot of sense. If Tomas, you have a follow-up question, please feel free to add it on our LinkedIn chat, or as well for those watching on YouTube or here through Zoom. Meanwhile, just I have a question for myself. I was wondering, people might have the misconception that any kind of GHG, or in this case CFR implementation, means to sacrifice production, which I believe, and I recall some cases in which is not the case. But I was wondering, from your point of view and having worked with the tool, have you found cases, or how often does it happen, that not only are you able to reduce the emissions, but even actually to perhaps optimize production, or at least keep it intact by reducing the intensity?
Yes, we have seen a case that I showed here on the ICBs in Suriname. So in that case, we didn't reduce the emissions, but we didn't reduce the production, but we reduced the emissions with the application of ICBs, so the intelligent completion. And we have had other cases where we were able to actually optimize the production with the reduction in emissions. So it's possible. It's quite challenging, I would say, but it is possible. But in most cases, we have to sacrifice the production by 1%, 2%. So it's a challenge, I would say.
Which is a small price to pay, a small production decrease for the sake of reducing emissions, which is also our priority. So in the end, it balances.
That's true. That's true, Rodrigo.
Thank you. And I don't know if there are other questions. I have many more, but I'm really curious about the presentation. But I don't know if there are other questions from our fellow members here in Zoom, on LinkedIn, or even there in Pau.
There's a more question coming from LinkedIn, which came from Tayyip, who is saying, super presentation, Ana Claudia. Can the ForCFR tool segregate emissions by scope 1, scope 2, and scope 3 when reporting progress on carbon footprint reduction?
So for the moment, not yet, because we only cover the first and second. So for now, we don't cover the other one. We don't really segregate among first scope, second scope, and the other ones.
Because the sub-scope.
Exactly. So we cannot accurately. Yes.
1 and 2.
That's true. That's true. And we cannot accurately estimate the CO2 emissions in the third scope.
I have a question. Did you try to implement your this procedure to CO2 EUR process? Because in this case, you should see the impact and CO2 intensity.
Yes.
Maybe it's too obvious, but
yeah.
Did you try, or do you plan to?
Yes, definitely. So maybe I can just repeat the question for the audience online. So it's been asked if we have tried to implement this for an EUR study.
CO2 EUR study,
CO2
where
EUR,
CO2
yes.
is unproduced CO2, either the CO2 produced
yes.
by the feed or CO2 capture CO2 from an industry. In this case, you should have negative.
Exactly. So we did a project on EOR. So and we saw that I cannot give too many details because it's quite confidential, but it's actually a project being presented in ADIPEC. But we saw that we had net emissions because we were injecting some gas, and we saw that the gas that we were injecting was being stored in the reservoir. So we were producing the oil, and we also had an aquifer. So the gas we were actually injecting was filling all the spaces that from where we were producing. And then we saw that because of the storage, we were recycling even less gas. So this is what caused us to have negative emissions at the end. Yeah.
Why don't you communicate? So interesting to
yes.
communicate about.
Yes, that's true. That's true. That's true.
Because your reduction are quite small.
Yes.
9%. small reduction compared
Yes.
to the work you achieve.
So 9% was actually because of field operations.
Yeah.
They were not very welcoming of some of the opportunities because that would compromise a little bit of their production. So that's why we were only able to achieve 9%. But if they were willing to sacrifice just a little bit of the production, I believe we would have more. But it's understandable. Thank you. Do we have any more questions here?
Yes, and just to add sorry, go
Yes.
ahead.
No, yes, Rodrigo. I don't think we have questions here.
We have a question online from LinkedIn from Samuel Ojidi. It's does ForCFR dynamically optimize process parameters like compressor load, pump efficiency, and separation pressure to minimize energy intensity while maintaining production targets?
Yes, that's actually some of the things we did right here in this slide that you're seeing in Angola study. As you can see here, we have gas lift pressure optimization. We have export compressor rebundling, where we touch a little bit of the pressure and efficiencies. And we also have water injection pumps pressure optimization. All this trying to reduce the CO2 emissions. So in this case here, I would say we sacrifice 1% of the production. But in other cases, it could be possible, yes, to actually not sacrifice the production. I would specifically talk about cases where we have brownfields and we have compressors that have been degraded. So we actually need to resize the compressors so we can have a better efficiency.
Thank you, Ana. And we have perhaps a final question here from Hervé Vigo. He's asking, how are the additional associated costs for opportunities to optimize production and reduce GHG emissions are used for overall ranking of opportunities?
Okay, I understand the question is on costs, right?
Exactly. How are the additional cost or opportunities to optimize production and reduce GHG emissions? How are they used to rank? So how is the variable, let's say, of cost being considered in the process?
Okay, so for this case in specific, we try to do it as zero capex, and for all the other fields as well, we try to do it at zero capex. We try to touch the least possible the capex, but I cannot really reveal the cost. That's quite confidential. But Hervé, if you wish, we can discuss later on.
Thank you, Ana. And we have a final question here from João, asking, how do you measure the efficiency of production and what factors are used to determine it with the used technology?
So I believe he's mentioning the ICVs.
Yeah, I think he refers, perhaps it's an overall question in terms of production efficiency. Perhaps, I don't know if he means in terms of mass balance or in terms of CO2 footprint, perhaps.
João, I see you're connected on the Zoom call. Feel free to unmute yourself and to clarify, please.
Yes, please. I'm not sure I understood the question.
Okay, the same question was out through LinkedIn, João, so we could reach to you offline just for the sake of time. And I believe, Ana, you can discuss with João offline that.
Okay, sure. I'll do that. Thank you.
Thank you.
Thank you, Constantine. Thank you, Ana. So before giving the last words to Ana and Poa, on behalf of SPE France and all of us here in Paris, we truly appreciate your time, Ana and Linfei and Happiness, everyone over there. It's a great presentation and a great tool. I've seen it and I keep on being amazed by it. Thank you so much for your time and sharing with us. And please feel free to add any final comment you would like to. And just a small parenthesis to remind everyone that we have our next event here in Paris, Distinguished Lecture, November 19th. So don't forget to join us. And of course, follow us on both LinkedIn, YouTube, Instagram now. And of course, if you're not a member, please consider joining and becoming one.
Thank you, Rodrigo. Thank you, everyone, attending this this presentation. If you have any more questions, don't hesitate to contact me on LinkedIn. I will be more than happy to respond. And we have an after work in a few minutes.
We have to talk about the SPs to the chapter.
Yes. Okay. Thank you, everyone, joining online.
Thanks, everybody. Wishing you to have a great after work in Pau. We feel a bit sorry that we are not able to join you, but thanks a lot for the amazing presentation. It was really eye-opener. Thanks, everybody, and take care.
Thanks, everyone. Bye-bye.
Bye.